Hello, today we are working on a Western Cullen Hayes crossing bell. This is model 333 and it is being restored for museum display. Now, what I'd like to mention is that this was made by Federal Signal. It was made in Chicago, and on the other side, which we'll show you later, it shows Western Signal. And we're going to use, for pointing out things, we're going to use a Pennsylvania Railroad Work Safety number 3 pencil. That's the best way to point at things. On the back, you'll see the circuit diagram. You'll see the wiring design here, and you'll see a lot of the specs. Note that this operates 6 to 17 volts DC, and it does tell you a positive and negative. There is a polarity here. So let's stop for a moment and look at the actual mechanism of this bell. Let's take a look at the operating mechanism. You have an electromagnet, and you have a metal bar that will close the magnetic circuit when it's energized, and that will come down, and it's mechanically connected to a hammer on the other side of the assembly. So if you push this down, the bell will sound. Now the circuit here is, you use your 12 volts. I'm using 12 volts. You can use between 6 to 17. I like the 12 volt supply. Here's your positive, here's your negative, and there's also a resistor for adjusting your current. But the most important adjustment I found is these two electrical contacts. When this is up, these two electrical contacts complete the circuit, so that when you apply your voltage across these terminals, the system will immediately engage and this will come down. Now, when this is down, these contacts become disconnected. The circuit is completely disconnected. The hammer will come back, cause the mechanism to come back up, and the cycle will repeat again. Once you made contact here, the coil is energized, and it starts, as you can see, it just goes up and down, up and down. Now, the problem we're having with this is that mechanically, this is not returning adequately. It's coming down, but as you can see, it's stuck in the down position. And this is a mechanical issue. Once it comes back up, it will make contact with these. Coils will re-energize and pull this down. When this goes down, these contacts become open, and there's no current going to the coils. Therefore, this will automatically come back up. Again, it's a cycle that keeps going up and down, up and down. I'll show you how far we've gotten with this so far. We'll energize the coils. As you can see, it's not really oscillating the way it should be. This needs to come back up, and it's just not operating properly, and a lot of this is because it's not coming back up. Now I pushed it back up to get it to operate, but it's not returning upward. I've lubricated various areas. The bell has been removed. That's the actual sounding part, the gong section. Here's the hammer that will strike the bell. The strike takes place right about here, and then this hammer will drop back and go back and forth back and forth. And I'm getting the impression that somewhere in this part of the mechanism, this axis, it either needs better lubrication or some kind of attention. There could be rust buildup inside this area here. I'm going to show you, power the bell real quick, show you the hammer move. Now apparently it's working good. So apparently there's something with regard to this, the movement here of the hammer, that's causing it not to go completely back and forth. I want to show you again how this mechanism works. This is a complete circuit. These two electrical contacts are closed when the bell is not in operation. When the power comes on for the bell to operate, this pulls down, this assembly will pull down, it's attracted by the electromagnets, the power is on, and when this moves down, these contacts are disconnected. With that disconnection, this is no longer, the electromagnets are de-energized rather, and then this goes back up, the circuit completes, this comes back down because the magnets have been energized. Let me show you with power on and you'll see what I mean. On the other side, the hammer is swinging back and forth. One of the things I want to point out are these contacts here. When you pull down on the mechanism, it tells you specifically in the instructions, hold this down entirely, as far as you can. And this gap here between the contacts and this shorting bar, this distance needs to be about 1/16 of an inch, and I believe I have it at exactly 1/16 of an inch, and that's worked out pretty well. But the real problem I'm running into is, we'll tilt the camera a bit, is this, there's a rod that goes through, it's an axle, and this drive, it's like a drive shaft actually. It goes through to the other end and the bell hangs from it, it's swung by it. This really needs to come back up a bit to make contact. And even when it does, it's not really doing it entirely. It's just coming up and it's just vibrating. But I found out that if I help push it up a bit, and I believe there's some degree of friction here in this drive axle, this drive shaft that is basically, which the bell is hung on. What I'm trying to do is loosen it up. I've used a number of products like WD-40. I've used a lithium product to try to loosen it up. It's getting a little better, but it's not ideal. Let me demonstrate with power on. As you can see, it does that, but then you can see it's just vibrating a bit. It's just vibrating up and down. You'll see it like oscillating, but not enough. But if I push down like this, if I help it move up a little, if I push it up, if I help it return to its higher position, to go up a bit, it functions well. See, it operates fine if I help it. So that's the trick right now, and I believe there's some resistance in this drive axle, and that's what's keeping it from free-flowing up and down the way it should be. So if you have any thoughts or suggestions, let me know.